This is the readout for Chapter 1.6, Problem Solving in Oblique Triangles. Now this chapter is just a quick review of the laws and the rules for solving triangles that we've looked at throughout this chapter. And we'll talk about the circumstances where to use each one, as well as a brief overview of each of the rules and tools that we have learned. And we start with the Pythagorean theorem. So the Pythagorean theorem, a squared plus b squared is equal to c squared, can only be used in right-angled triangles. It can only be used if we have a triangle with a right angle involved. If we do have that case, then the lengths a, b, and c always has to be the hypotenuse, the longest side, and a and b, the two legs of the triangle. So Pythagorean theorem, you're always able to use with a right angle triangle and given two sides to find the third one. Make sure though that your hypotenuse is always the c value. It involves the three sides. Next, we have primary trigonometric ratios. SOHCAHTOA is what we use to remember the formulas for sine, cos, and tan. Now this involves labeling a triangle's three sides with the labels the hypotenuse, the opposite side to the angle in question, and the adjacent side. So SOHCAHTOA can help us remember that the formula for sine of an angle theta is equal to opposite over hypotenuse. Cos of an angle theta is equal to adjacent side over hypotenuse. And tan is equal to, or tan of theta is equal to the opposite side over the adjacent side. Once again, SOHCAHTOA only works for right triangles. If you have a non-right triangle, an oblique triangle, you cannot use SOHCAHTOA. But if given a right angle triangle and you have information on sides and angles and the third piece that you're trying to find, SOHCAHTOA is the quickest way to solve that. More recently, we looked at two laws for oblique triangles, the sine law and the cosine law. Both are used to solve for side lengths and angles in a non-right angle triangle or an oblique triangle. Now, sine law is used when you have a matching side and angle combination, such as in your diagram you have both side A and angle A, or both side B and angle B, or both side C and angle C. And drawing the connecting patterns can shape an X symbol within your triangle, an X pattern with one unknown. Conversely, you can use the angles to find side lengths by flipping the numerators and denominators. Another version of sine law is sine A over A is equal to sine B over B, which is also equal to sine C over C. And once again, recall that the capital letters, capital A, that's angle A. Lowercase letters always mean the side A or side B. Cosine law is the other tool we have to solve oblique triangles. This is used when we don't have a matching side and angle combination. A cosine law is c squared is equal to a squared plus b squared minus 2ab cos c. This is when a T pattern can be formed, but it basically breaks down into two situations. One where we have a side, then an angle, and then another side in a row. Or secondly, if we have all three sides but no angles, side, side, side. And in that case, we can use a rearranged version of cosine law with cos c just on one side that we talked about in the previous note in 1.5. So given a triangle, we have these four tools to use. Before diving into the question, take a pause and ask what type of triangle we have. Is it a right angle triangle? Is it an oblique triangle? And then narrow down which tool we should use to accomplish what we're trying to solve. A good starting step is always to sketch a diagram if there isn't one given. To solve a triangle ABC, Now we should talk about what the word solve means when talking about triangles. To solve a triangle means to find all three side lengths and all three angles. Now, a lot of questions don't require you to fully solve a triangle. Most questions just say, solve for side length A or solve for angle C. In that case, we don't have to fully solve. We just have to find the value that the question asks for. But to fully solve means to find all three sides and all three angles, which is a larger question. If a diagram isn't there, a good idea is always to start by sketching a diagram. If your triangle is a right triangle, then you can use the Pythagorean theorem or SOHCAHTOA, the primary trig ratios. If your triangle is not a right, if it's an oblique triangle, then you must use sine law or cosine law. You cannot use Pythagorean or primary trig ratios. Now, if you really wanted to, sine law and cosine law also work on right angle triangles, but they're a lot more work. The sine law and the cosine law, as you can see, are larger equations. They're more complicated to use than just Pythagorean theorem or SOHCAHTOA. So I would recommend not using sine law or cosine law on a right angle, although technically it would still work, but it is more work on your part. Lastly, there is a final tool that we always have when dealing with triangles, the interior angle theorem. In any triangle, the sum of angles in any triangle always has to add up to 180 degrees. This is useful. Whenever you have two angles, you can very quickly find the third angle by just subtracting the given two from 180 degrees. So if you are stuck and unsure what law to use and want one more piece of information, use this interior angle theorem to find that third angle. Then oftentimes one of the tools available will be more obvious. So solving triangles. That's our review of 1.6 from the previous few lessons. The questions on this chapter vary in sine law, cosine law, Pythagorean, or SOHCAHTOA. So when trying these practice questions, take a minute in each case to decide what type of triangle you have and which tools, which laws you should be using. Below we have not only the textbook answers, but as always the full solutions. Good luck, and we will talk to you later.